In this video, I will introduce the chain rule with examples. This is the differentiation rule we need to take derivatives of compositions of functions. For now, I will only present some examples of calculations. I won't even write a general formula yet. In the next video, link in the description, I will state the chain rule formally as a theorem and try to prove it. For my first example, I want to compute the derivative of the square root of x cubed plus 1 with respect to x. If it were just the square root of x, it could be easier. The derivative could be 1 over 2 root x. The chain rule says that to take the derivative of the square root of a function, instead of just the square root of x, I should first take the derivative the same way, as though the argument of the square root were the variable. So 1 over 2 times root of x cubed plus 1. But then I have to multiply it by the derivative of the argument. In this case, the derivative of x cubed plus 1. We know the derivative of x cubed plus 1 is 3x squared. And that is the final answer. For my second example, I want to take the derivative of sine of 6x with respect to x. The derivative of sine of x with respect to x is cosine of x. Side comment. At this point in the sequence of videos, I have not studied derivatives of trigonometric functions yet. Perhaps you already knew this identity. If you didn't, just accept it for now. I will justify it soon. The point of the problem is, once we know the derivative of sine is cosine, what is the derivative of sine of 6x? The chain rule says, first take the derivative as though the argument 6x were the variable. I get cosine of 6x. And then multiply times the derivative of the argument, the derivative of 6x. We know the derivative of 6x with respect to x is 6. So the final answer is 6 cosine of 6x. For a third example, let's compute the derivative of x squared plus 1 to the 100 with respect to x. I could expand this, write it as a long polynomial, and take the derivative, but I don't want to do that. Instead, I can use chain rule. The derivative of x to the 100 with respect to x is 100x to the 19. The chain rule says, first pretend the argument x squared plus 1 is the variable. I get 100x squared plus 1 to the 19. And then multiply times the derivative of that argument, the derivative of x squared plus 1. We know the derivative of x squared plus 1 is 2x, so I get 200x times x squared plus 1 to the 19. And that is the final answer. These examples illustrate how we use the chain rule in practice. But I still haven't even written the statement of the chain rule properly as a theorem for arbitrary functions. The notation is a bit subtle. I will present it in the next video and I will try to prove it.